Is the shift from fossil fuels to green energy really a cakewalk? Not at all. It's really complicated. But amidst this complexity, there is a beacon of hope: green hydrogen. So where does this green hydrogen fit into the whole energy equation? Let's explore its potential and the hope it brings. Fossil fuels are running out. Fortunately, chemical engineers are not running out of ideas to keep the world running. Energy is at the heart of both the cause and the solution of the climate crisis. Burning fossil fuels to produce heat and electricity results in the production of a significant amount of greenhouse gases, which cover the earth and trap solar radiation. Fossil fuels, which include coal, oil, and gas, are by far the primary source of climate change, contributing over 75% of global greenhouse gas emissions and nearly 90% of carbon dioxide emissions. The science is clear. To prevent the worst effects of climate change, emissions must be reduced by almost half by 2030 and reach net zero by 2050. This is not just a goal, but a necessity. To do this, we must reduce our dependence on fossil fuels and invest in clean, easily available, reasonably priced, sustainable, and dependable alternative energy sources. Here comes the importance of the chemical engineers we mentioned earlier. These unsung heroes are the silent designers who are playing a crucial role in mitigating the risks of climate change, building a better future for us, and saving us from the possible threats of climate change and mass extinction. Their efforts deserve our appreciation. One big name in this field is Yasmin Ali, the author of Power Up. Ali is one of the UK's leading chemical engineers. She and others in electrolytic hydrogen production are turning water into hydrogen fuel. According to her, hydrogen is the most abundant element in the universe. Let's return to hydrogen, where Yasmin Ali is doing her best and smart work to create a better and healthier future for everyone. Before that, we are trying to make you say in simple words that the shift from fossil fuels to green energy sources is not just swapping one fuel with another. It has a much bigger impact on all key areas, including geopolitics, the economy, technology, and the environment. As we said at the beginning of the video, the shift from fossil fuels is very complicated. In the years to come, hydrogen, the final piece lacking from the clean energy puzzle, is probably going to further overturn energy value chains. This renewed focus on hydrogen policy is mostly due to the pressing issue of climate change. By 2050, clean hydrogen might account for up to 12% of total energy usage, according to IRENA's 1.5 degrees Celsius scenario. When it comes to hydrogen, do you know what the attractive part is? It's storage and transportation. H can also make it easier to ship and use pipelines to move the energy produced by renewable sources over larger distances, opening up untapped renewable resources in isolated areas. With technical adaptation, some natural gas pipes that are already in place might be used to transport hydrogen. Countries worldwide have set the goal of decarbonizing the planet by 2050. One way to do this is to decarbonize the manufacturing of an element like hydrogen, which results in green hydrogen. At the moment, this accounts for more than 2% of all CO2 emissions worldwide. These days, green hydrogen has been in the headlines a lot. In order to create green hydrogen at a lower cost than natural gas, Biden has pledged to employ renewable energy sources. The Department of Energy is investing up to $100 million in fuel cell and hydrogen research and development. To assist in achieving the objectives of this Green Deal, the European Union plans to invest $430 billion in green hydrogen by 2030. Furthermore, large investments in green hydrogen are being made by Australia, Chile, Germany, Japan, Saudi Arabia, and Germany. So what is green hydrogen then? For those who are still confused, in short, it's hydrogen fuel produced without the use of fossil fuels by means of renewable energy. What is the source of green H? Hydrogen energy is extremely flexible since it may be produced in a variety of ways, used as fuel or as a gas, and turned into electricity. Global production of hydrogen is already estimated to be 70 million metric tons annually and more. However, individual H atoms are not found in nature. Hydrogen can only be created when its atoms are separated from other elements, such as those found in plants, water, and fossil fuels. The bottom line is that the sustainability of hydrogen energy depends on how the separation is accomplished. Did you know that the majority of the H used today comes about through a process known as steam methane reforming? In this process, a catalyst is used to create methane with high temperatures to produce hydrogen, carbon monoxide, and trace amounts of carbon dioxide. Pure hydrogen remains after the carbon dioxide and other impurities are removed. In order to create H through steam reforming, this fossil fuel-based production process produces gray hydrogen and 830 million metric tons of CO2 emissions per year, which is equivalent to the emissions of Indonesia and the United Kingdom put together. Blue hydrogen is the H created when the CO2 from the steam methane process is removed and stored elsewhere. One factor contributing to the increased interest in green hydrogen is the quickly falling cost of renewable energy, since eliminating emissions from some sectors of the economy is challenging. The majority of experts believe that green H will be crucial in meeting the goals of the Paris Agreement. In the US, 3 industries, transportation, electricity generation, and industry, are the largest contributors to emissions that cause global warming. The production of electricity and some transportation-related emissions can be reduced by energy efficiency, renewable power, and direct electrification. However, the remaining 15% of the economy, which includes shipping, long-distance trucking, aviation, and the manufacturing of steel and concrete, is difficult to decarbonize because these industries need high energy density fuel or intense heat. These needs could be met by green hydrogen. Green H has the unique benefit of being produced anywhere where there is water and power, which may be used to make more heat or energy. Are there any disadvantages for green hydrogen? Yes, the main issue is that hydrogen is more inflammable than other fuels, so it should be handled with extreme care. Since it's 57 times lighter than gasoline fumes, we can relax, as it can quickly disperse into the atmosphere, making it safe. Transporting H is challenging as it is so much less dense than gasoline. It must either be compressed to 700 times atmospheric pressure in order to be supplied as a compressed gas, or cooled to -253 degrees Celsius in order to liquefy it. At the moment, there are several ways to transport H: by rail or barge, in tube trailers that carry gaseous hydrogen, in low-temperature liquid tanker trucks, or through dedicated pipes. So what do you think? Will green H allow a seamless transition from fossil fuels to green energy? Tell us in the comments. If you enjoyed the video, give it a like and also subscribe to the channel. Until next time.